Namaste everyone. So last class we started with real numbers. Okay. Today's lecture 2. Just let's quickly revise whatever we learned in lecture 1. Now I will not do this revision every day. Okay. I will not do this revision. You have to do this before joining the class. Please revise and come everyone before you join the next class. Okay. You have to revise everything. So what did we learn in lecture 1? We learned what is natural number. Natural number starts with 1 and goes up to infinity. Whole number starts with 0 and goes up to infinity. We learned that all natural numbers are whole numbers, but all whole numbers are not natural numbers. Why? Because 0 is a whole number, but not a natural number. Okay. Next, we learned what do you mean integers. Integers include 0, positive numbers and negative numbers. Next, we learned what do you mean by factors. So factor are the exact divisors. The best way to remember them are, they are the exact divisors. They are the exact divisors. So for example, if you take the number 1, the factors is 1. If you take the number 2, the factor is 1 and 2. If you take the number 3, the factors are 1 and 3. So if you see, all these numbers are the exact divisors. They are the exact divisors. Okay. So in that, we learned what is a prime number. A prime number is a number which has got exactly 2 factors. Okay. Next, composite number is a number which has got more than 2 factors. And we learned that 1 is neither prime nor composite, 2 is the smallest prime number, and 4 is the smallest composite number. Okay. See, I have taught all this in detail. I'm just revising. Okay. Don't expect to understand everything just in this revision. It's not possible. You should have revised this by yourself first. Okay. Next, we learn what is multiples. If you multiply a given number, you get the multiples. 2 into 1, 2 into 2, 2 into 3. You can multiply 2 with 1000 also. 10,000 also you can multiply. That is why we get infinite multiples for any given number. You get infinite multiples. But factors you can count. They're limited. Okay, but multiples are infinite. You cannot count them. Okay, it goes on. It's endless. Next, we learn what is the meaning of HCF. So I took two numbers 6 and 12 and I showed you that 6 is the highest common factor. We learned that the HCF is the largest number which divides a given number. 1 can also divide, 2 can also divide, 3 can also divide both of them. But 6 is the largest number which divides both of them. So you have to remember that HCF is the largest number which divides a given number. Okay? We saw a few more examples here. Then LCM, we moved on to LCM. So least common multiple is the smallest number which is divisible. If you look carefully, 6 is divisible by 2 and 3. 12 is also divisible by 2 and 3. 18 is also divisible, but 6 is the smallest number which is divisible by 2 and 3. And I told you this technique will not follow for solving questions. We'll follow the technique of factorization. And for that, we need to know the fundamental theorem of arithmetic. I've explained this theorem with examples. Okay. I hope you remember it. I cannot repeat this. Okay. So we learned how to find the HCF and LCM by prime factorization. So you take the numbers, whatever they have given, whatever numbers they have given, take it and like write as a product of prime factors. Write as a product of prime factors as per this theorem. You can write any composite number as a product of prime numbers. So 6 we are writing as 2 to the power 1, 3 to the power 1 because it is occurring one time. And 20 is 2 to the power 2, 5 to the power 1. While finding HCF, we have to take common and put lowest power. And while finding LCM, you have to take all the prime factors and put the highest power. Remember that. Remember that. So in HCF, we have to take common. So common is 2 and lowest power is 1. So 2 to the power 1 is 2. LCM, don't see common. All the prime factors you take and put their highest power. Their highest power. So 2 is there. So 2 highest power is 2. That is why 2 highest. 3 is there. 3 highest power is 1 and 5 highest power is 1. You multiply again. We also found that if you have two numbers, just two numbers, HCF of the two numbers into LCM of the same two numbers is the product of the two numbers. Very, very, very important. I can take two numbers as X and Y also. That means HCF of two numbers X comma Y into LCM of the same two numbers X comma Y will be equal to what? X into Y. Okay. So we solved these examples also. Like this question is board question basically. So we had to find the HCF and LCM of these three numbers. So take the numbers, write as a product of prime numbers. Okay. This was not there actually. I just gave this to explain. Okay. I hope you remember that. So 12 is 2 to the power 2, 3 to the power 1. 21 is 3 to the power 1, 7 to the power 1, 15 is 3 to the power 1, 5 to the power 1. While taking HCF, see common and lowest power. See, common is only 3. 3 is there in all the 3. Okay. So take common lowest power. And while taking LCM, don't say common. All the prime factors, put the highest power. That is what I've given here. When it is HCF, we have to find the product of the smallest power of each common prime factor. But in LCM, product of the greatest power. See, here only only one number is common, that is 3. That is why we are not finding the product. If 2 numbers are common, we have to find the product, right? That is why product of the smallest power. Okay. So product of the smallest power of each of the common prime factors occurring in the numbers, and LCM is the product of the greatest power of each prime factor. There is no common here. Each prime factor we have to take involved in the numbers. Yes or no, everyone? Yes or no, everyone? I hope, see, only if you have revised, it will become easy. Otherwise, it will not become, it will get tougher day by day. It will get tougher day by day. Okay. And see, I have taken 7 minutes just to tell all this. Okay. And I have few more things here. We have discussed these questions. Okay. So if this 7 minutes I can utilize to do something else also. Akhil, you have to switch on the video. Please do it right away. Okay. All of you, please switch on the video. I should not be asking every day. Okay. Keep it on. Otherwise, I'll actually better remove you from the meeting itself. You take a rest. To next class, you join. You watch the recording. Akhil, are you there or not there?
Yes, sir.
And then switch on the video. Naren, please switch it on. Okay. So this question also we solved, right? Now, I have few more board questions. We'll actually be solving those in this today's class. Okay. Yeah. All of you solve this question, put the answer in the chat box. I will switch off my video, but you don't switch it off. Okay. I'll switch it for some time. I'll be there only. You try out these questions and put the answer in the chat box and keep your video switched on. All of you first try, and those who are right, no? Those who are right with the answers, I will not put any reaction in the chat box. If it is wrong, only I'll put a thumbs down. So as of now, Dayalan, Likit, and Arush have answered. All of them are correct. Very good. If it is wrong, only I'll put a thumbs down. Otherwise, I will not put any reaction in the chat. Okay. All of you try. Very nice. All of you got it right. Very, very nice. That means you all have revised. Okay. And it's actually a very simple question also. Okay. It says if x into y, okay, xy means x into y. If x into y is 80, 180, sorry, and HCF of x comma y. So that means x and y are two numbers. Okay. HCF is 3 and find the LCM. See, we know the relationship. We know the relationship. We know the relationship HCF of two numbers x comma y into LCM of the same two numbers x comma y is equal to product of the two numbers. Okay. So what is HCF 3? What is LCM? We have to find out. Is equal to 180 because x into y is 180. So what is LCM of x comma y? 180 by 3. If you simplify, it'll get 60. Okay. So the answer is 60 and everybody has got it right. Very good. Okay. Okay. And Surajit, I want to show you that everybody has answered except you. Okay, I can show you. Let me show you. Okay. That means you have to actually do a lot of hard work, okay? So nothing comes easy in life, okay? Please understand that. Just you don't come for the just don't come to the classes for actually just watching it. You have to do work at home also. You have to write the class notes. You have to practice questions, okay? Then only you'll get results. Just come attending the class will not help at all. Please understand that, okay? So everybody has answered except you, okay? Okay, fine. Next, let's move forward. Okay, before I give the next question, no, I'll teach you a small concept, okay? I'll teach a small concept. Now, suppose they have given two numbers in the prime factorized form. Okay, actually, they'll give in variable form. So suppose I have two numbers x and y. Suppose I have two numbers x and y, okay? I have two numbers x and y. And x is equal to, for example, okay, x is equal to, for example, x, just 1 minute. I have actually changed the pen size. That is why it is disturbing. Just 1 minute. Huh? Yeah. Suppose x is equal to a to the power 3 into b to the power 2 into c. Okay. A, B, C are some prime numbers. Okay. So I have written x is equal to, see, suppose if I have maybe 20. Okay. I can write 20 as 2 tens are, 2 fives are, 5 ones are, right? So I'm writing 2 to the power 2, 5 to the power 1, right? So same way, x I'm writing as a to the power 3, b to the power 2, c to the power 1. C means c to the power 1. Yes or no, everyone? And suppose y is equal to, suppose I'm saying, suppose y is equal to a to the power 2 into B, just this one. Okay. What is A, B, C? They are actually prime numbers. And X and Y are the two numbers, and we are writing this as a product of prime numbers. Okay. Now, suppose they ask us, find the HCF in this case. All of you listen, don't have to tell me the answer. HCF of X comma Y. See, I told you to find HCF. First, see common. What is common? A is common, B is common. And in that, what is lowest power? See, A power lowest power is 2 and B lowest power is 1. Therefore, HCF is A square into B. Yes or no, everyone? Yes. Next, what is the LCM? While finding the LCM, don't take common. Whatever prime factors are there, write it and put highest power and multiply. A to the power 3, B to the power 2, C to the power 1. So I can write A cube B square C. Yes or no, everyone? A cube B square C. Can you all try this question? If you have understood this concept, just go through once. If you have doubt, you can ask. Just go through. If you have doubt, you can ask. Otherwise, I'll give you another question of similar type. Okay. They'll give in variables basically. I will try it out. Try this question. And put the answer in the chat box. I want options A, B, C, D. You try it out. Don't do any guesswork here. Do it step by step and put. Okay. I'll switch off my video, but you keep it on. We will discuss that. Dhalan will discuss. Okay. We'll discuss. Surajit, send me your working out on WhatsApp, okay? I want you to send me your workout in WhatsApp. Okay, Surajit, do it. A, B, C, D, like, Srivatsa, can you put A, B, C, D? Can you put A, B, C, D? So only Srivatsa, Arush, and Surajit, they are right. Very good. We'll discuss. It's actually very simple. Even, yes, we'll discuss. It's very simple. All of you listen. Don't write anything. Just listen, okay? Just listen. If two positive numbers A and B. So here numbers they are given A and B. See, earlier I took X and Y. See, they can give anything, okay? See, here numbers I have taken X and Y. But here in the question they have given A and B. They can interchange, no? Anything they can do, right? So two positive numbers A and B are written as, so A they are writing as x to the power 3 and y to the power 2. Okay? And B, they are writing as x to the power 1 into y to the power 3. Nothing is there means into. Where x and y are prime numbers. See, they have actually given that they are prime numbers. Even if they don't give, it is understood, self-understood. Okay, even if they don't give, it's understood that these are prime, x and y are prime numbers. Because we are writing something as a product, right? So obviously they're prime numbers. Okay. Then the result obtained by dividing the product of the positive integers by the LCM of A comma B. Okay. Look very carefully, everyone. You have to understand this question. What are the two numbers they have given? Two numbers they have given are A and B. They are telling the result obtained. What result? Dividing the product of the positive integers. See, if you divide the product of the positive integers by the LCM, what is the result they are asking? The result obtained by dividing the product of positive integers. See, product of positive integers is A into B. Product of positive integers is A into B because those are two positive integers by the LCM of A comma B. By the LCM of A comma B. See, which are the two numbers? The two numbers are this one. So x to the power 3 into y to the power 2 into B is what? X to the power 1 into y to the power 3. And what is the LCM of A comma B? I have told you to find the LCM of the two numbers. Don't take common. Whatever number is there, put the highest power. So LCM is x to the power 3, y to the power 3. Yes or no, everyone? Yes or no, everyone? So x to the power 3, x to the power 3 gets cancelled. X to the power, y to the power 3, y to the power 3 gets cancelled. X to the power 3, x to the power 3 gets cancelled. What we are left with? Y to the power 2 into x to the power 1. They have not given any, like in that order. They have actually written x first and then y. See, x to the power 1, it's not there means 1 is only the power, right? So the answer is option B. Have you all understood? If anybody is having a doubt, you can ask. Just check. Okay. Naren understood? Very nice. Can you all try a similar question? Please don't search any of these answers in Google. Okay. Surajit, did you send me the working out on WhatsApp, Surajit? So 3 people have got it right. Dalan, Santosh, Kumar, and Naren. See what's a very nice. Very nice. Yes, like it will wait for some more time. Maybe Arush and Akhil. Let them try. Discuss. Very good, Arush and Akhil. Right. Let's discuss exactly very simple. We'll discuss. Okay. Let A and B be two positive integers such that A is equal to P to the power 3, Q to the power 4. So A they have given us P to the power 3, Q to the power 4. And B they have given us P to the power 2 into Q to the power 3. Just 1 minute. Next, where P and Q are prime numbers. If HCF of A comma B is P to the power M, Q to the power M. See, what is the HCF of A comma B? HCF of A comma B is what? If you look, HCF of A comma B, see, to find HCF, we'll take common first and put lowest power, so P to the power 2 and Q to the power 3. And they've told that is equal to what? And that is equal to P to the power M into Q to the power N. See, if you compare, if these two are equal, if you compare, power will also be equal, right? If these two are equal, see, power of P will be equal, it has to be equal, right? That means M will be equal to 2 and N will be equal to 3. N will be equal to 3. Next, LCM of A comma B is what? LCM of A comma B is what? While taking LCM, don't take common. Okay. You don't have to take common. Here, there is common actually. You don't have to take common. You take all the prime factors and put highest power. So if you compare with P to the power R into Q to the power R, sorry, Q to the power S, what will be R? And what will be S? So we have found out all the numbers. And therefore, M plus N means what? 2 plus 3 into R plus S, 3 plus 4 will be equal to what? 2 plus 3 is 5 and 3 plus 4 is 7. Answer is 35. Okay? Answer is option C. Check all of you. Check all of you. Check all of you. Okay. Can you all try this question? Assertion reasoning type question. And one more thing, before you try, all of you listen. You all have to learn these 4 options by heart. You have to learn it. In the exam, you should not spend time reading both A and R that are true and R is a correct explanation of A. Both A and R are true and R is not. You should not spend time in reading all this. You should know what is A, what is B, what is C, what is D. You should know it. You have to learn it. You have to save time in all these things. Okay, do it, everyone. Those who got wrong will discuss. We'll wait for some more time and then we'll discuss. And all these are board questions, okay? Let's discuss. All of you listen, we'll discuss. If product of two numbers is 5780, if product of two numbers is 5780 and their HCF is 17, then LCM is 340. We have to check whether this is true or not. We have to check. Okay. Now we know that HCF of two numbers into LCM of the same two numbers is equal to product of the two numbers. HCF of two numbers is 17 and LCM is 340. Now, what is the product of two numbers? It's already given. 5780. Now we'll check whether this is equal to this. If this is equal to this, then it is true. Then only HCF will be this one and LCM will be this one. Okay. So let's actually multiply and check. I'll do it. So if you multiply 17 into 340, I'm getting yes. That means this is true. Okay. This is true. HCF is always a factor of LCM. Now see, you can understand this result by lot of ways. Okay, I can explain this by lot of ways. I'll explain one way. I'll give one example to make you understand. Okay. Now, you know what is the meaning of factor? Factor means exact divisors. So HCF is an exact divisor of LCM. HCF is always a factor of LCM means what? HCF is going to be the exact divisor of LCM. Okay. We have learned that HCF is the largest number which divides a given number. Okay. What we have learned? HCF is the largest number which divides a given number. Okay. Now, suppose if I have number maybe 5 and 10. Okay. If I have numbers 5 and 10. So 5 you can write 5 to the power 1 and 10 I can write 2 to the power 1 and 5 to the power 1. So what is the HCF? HCF of 5 comma 10 will be 5. And what is the LCM of 5 comma 10? 10. Because Don't have to take common, put highest power of each of them. 2 to the power 1, 5 to the power 1. So it will become 10. Okay. Now look carefully, everyone. If you see, HCF divides HCF can divide LCM. HCF can divide LCM. See, HCF can divide LCM. So HCF is a factor here. Okay, you can take some more examples. You will find that HCF is going to be always a factor of LCM. Another way to understand is, see, if HCF is, see, what is HCF? HCF is the largest number which divides this. HCF is the largest number which divides this. And LCM are the multiples of this, right? LCM are the least common multiples of this, right? See, if HCF is able to divide this, multiples also will be divisible only, right? See, if HCF is able to divide these two, multiples also will be divisible, right? Yes or no, everyone? Yes or no, everyone? If HCF is able to divide these two numbers, even multiples it can divide, for sure. That is why HCF is always, always, always a factor of LCM. Is that clear, everyone? So this is also true. This is also true. Both are true. Now I have told you, actually only round 1 I have told. Yes, round 2 I'm telling for everyone right now. See, whenever you want to check whether assertion is the correct explanation of this one, apply because. 99% of the cases it will work. 99% it will work. Okay, mostly for you it will work. Okay, in higher levels actually it doesn't always work, but 99% it works. Okay, now if the product of two numbers is this one and the HCF and LCM is this, then LCM is 340. Is it because HCF is always a factor of LCM? Is it because of that? No. We are getting this result from this one, right? We are able to verify all this. Because of this, right? Not because it is a factor. Not because it is a factor of LCM. This is true, but it is not because of this we are getting this. No. That is why answer is option B and not option A. Yes or no, everyone? Clear, no? Yes or no? If you have some doubt also, an iota of doubt also you can ask. Okay, if you have some doubt also you can ask. Okay, so apply because and check. You will get it. 100% I'm telling you, you'll get it. Okay. Yes. Okay. Just give me 1 minute, then we'll solve some questions. Okay. So let's discuss another set of questions. Okay. Another set of questions, which is also asked in the board exam. See, first look at the question. Don't look at the solutions right now. Just look at the question. Okay. Find the largest or the greatest number which divides 6 and 20, leaving no remainder. Leaving no remainder means what? Exactly divisible. Okay. So we have to find the largest or greatest. See, whenever you want to find the largest or the greatest number which divides, we always have to find the HCF. Because what is HCF? It is the largest number which divides. It is the largest number which divides. So whenever you want to find the largest number which divides, you have to find HCF. So you have to remember this. That is why, see, I have written the solution because I don't want to waste time here. Okay, you know what? You should know what to find. After that, you can find. See, HCF of 6 and 20, you can easily find. HCF of 6 and 20, you can we have already done this. We have already found out the HCF of 6 and 20. We have already done it. Okay. So steps I have written for you. What are the steps? First, write one statement. The largest or the greatest number which divides 6 and 20, leaving no remainder, is HCF of these two numbers. And then you have to use prime factorization to find the HCF. Prime factorization. So take 6. You can write 6 as 2 to the power 1, 3 to the power 1. How it came? 2 3 is 6, 3 1 is 3. 2 to the power 1, 3 to the power 1. 20. 20 if you take 2 10s are, 2 5s are, 5 1s are. 2 to the power 2, 5 to the power 1. While finding HCF, we take common, put lowest power. After getting answer, we'll write one conclusion. Therefore, the largest or the greatest number which divides 6 and 20, leaving no remainder, is 2. Clear, everyone? See, you know how to find HCF. Okay. That is why I've just written the steps so that in the exam you write steps, because you have step marks, right? Just answer alone will not fetch you full marks. You have write steps. Okay. Next question. Find the largest number or the greatest number which divides 288 and 420, leaving no remainder. Again, you have to find HCF here. Okay. So at home, you please practice these questions. at home, see, similar type of question if you do, right? Similar type of question. You know you have to find HCF. If you keep finding HCF, we are wasting time actually. Okay. If you keep finding, you know how to find HCF, you should know what is the procedure and you have to practice at home. Okay. You have to practice at home. So the greatest or the largest number which divides 288 and 420 leaving no remainder is HCF. You find the HCF and then write the conclusion. That's all. Clear everyone? Yes or no? Yes. Next, find the smallest number. So largest number we have seen. See, if it is largest or greatest number, we have to find HCF. If it is smallest number or the least number, we have to find LCM. That's all. So the smallest number or the least number which is divisible by this is what? LCM of these. So find LCM and then write the conclusion. Yes or no, everyone? Yes or no, everyone? You can do it. All these things is very, very simple. Okay. Don't think I'm rushing. I'm not rushing. Okay. I'm not rushing. Actually, I'm not rushing because we have done so many board questions also. And in those board questions also, we have to find HCF and LCM. So you know how to find HCF and LCM. The same thing if you do with different numbers, there is no point. You're wasting time. Trust me. Okay. You can do all those practice at home. Okay. So find the smallest or the least number which when divided by 672 and 120 leaves no remainder. So for this also we have to find LCM. Okay. Because LCM is the, yes, tell me.
Sir, all these were do it in class notes or
class notes. You have to practice also and you have to do it in class notes. Yes, you have to write in class notes. Yes. See, all of you, when you write class notes, it will be very good for you to revise at the end. Okay, towards the end, you'll keep searching what to revise, what not to revise. This will actually act as a revision also. Okay. And don't think these are important. Everything is important. If you're here to score centum, everything is important. And don't come here with the mentality of getting 80 or 90. You should aim for centum. Okay, that should always be your aim. Okay, centum should be your aim. Okay, nothing less than that. Yes, next. Find the largest or the greatest number which divides 70 and 125, leaving remainders 5 and 8 respectively. Yes, this is very important. Okay, now here, we have to find largest or greatest number. See, whenever largest or greatest number we have to find, it is HCF. But in this question, they're saying leaving remainders 5 and 8. That means when you divide 70, right, you will get remainder 5. And if you divide 125, you'll get remainder 8. Okay. I repeat, because after dividing, we are getting remainders. That means if you divide this 70 by that number, you'll get remainder as 5. And if you divide this, you'll get remainder as 8. That means if you remove the remainder, see, suppose I have number 5. Suppose I have number 5. If I divide by 2, I'm getting 2 to the 4, remainder is 1. See, if I remove 1 from 5, it will be exactly divisible. Yes or no, by 2? Yes or no? If I remove 1 from 5, it will become exactly divisible by 2. Same way, if you remove the remainder from these numbers, the numbers which you get, if you remove the remainders, if you remove 5 from 70, you'll get 65. And if you remove 8 from 125, you'll get 117. That means these two numbers will be exactly divisible. These two numbers will be exactly divisible because you are removing the remainders. You are removing the remainders. Just because you are removing the remainders, these numbers will be exactly divisible. Exactly divisible. Okay. So whenever they give a question, find the largest number which divides this and this, leaving remainders, remove the remainders, and then find the HCF. Okay. And whatever answer you get, what the HCF, that will be the answer. Okay. So you write one statement. These introductions are very, very important. You have to write it. The largest or the greatest number which divides 70 and 125, leaving remainders 5 and 8 respectively is HCF of 70 minus 5 and 125 minus 8. 125 minus 8. Because this will leave remainder 5, right? So subtract from here 5. This will leave remainder 8, right? So subtract 8 from here. Yes or no, everyone? So this statement is very, very important. It carries marks. This carries actually 1 marks. This itself carries 1 marks. This itself you will not believe. Okay. You have to write this. Okay. And don't think I have written my own thing. Okay. I have actually taken from answer keys and all. Okay. Don't think just I have formed something I written here. It's not like that. Okay. So it like lot of homework also I have done. Okay. It's not like I know everything. I also have to do a lot of homework at home. Okay, I have to read, I have to make questions. Okay, a lot of things are there. Okay, so you know how to find HCF of these two numbers using prime factorization. Do it, and whatever answer you get, write one conclusion. Yes or no, everyone? Yes. Next, find the smallest or least number which, when divided by 12, 21, and 35, will leave the same remainder 6 in each case. See, you know that LCM is the smallest number which is divisible by the given numbers. Okay. You know, LCM is the smallest. So whenever you want to find the smallest number, you have to find LCM. But you want remainder 6 in each case. So what you do is, here the steps are a bit different. You have to first find the LCM of these numbers and add 6. You have to first find the LCM of these numbers and add 6. Then I will keep getting remainder 6 in every case. Okay. So the smallest number, which when divided by 12, 21, and 35, will leave the same remainder 6 in each case, is what? You first find the LCM of the numbers and add a 6 to that. Yes or no, everyone? For example, you see here we have got the answer as 420. You will add, okay, sorry, we got answer as 1 minute. So it will be 426. Okay, it will be 426. Okay, it's a mistake here. So it's actually 426. Why 426? All of you look carefully. See, if I have 420, if you divide 420 by 12, okay? If you divide 420 by 12, okay? 12 threes are 36. Okay, 6, 0, 12 fives are 60. Remainder is coming out to be 0. But since you want remainder to be 6, you have to add plus 6 in, okay, after getting the LCM. So that is what I've written here, no? Maybe I forgot to write here, okay? So you have to add actually a 6. So the answer will be LCM plus 6. So after finding LCM, you write one answer that the smallest number which one divided by 12, 21, and 35 will leave the same remainder 6 in each case is 426. How? We have written it here. LCM plus 6. Okay. Yes or no, everyone? Yes or no, everyone? Yes. Okay. So if you're logically right, even if you make a mistake, you'll come to know your mistakes. Otherwise, if you're learning something, right, you'll actually always keep making mistakes without realizing your mistakes. Okay. Yes. Now let's do the most important question. Okay, this one. Okay. All of you, first you listen. Okay. I will teach concepts and then you can do it. Okay. All of you listen. 3 bells tall. Tall means ring. Okay. 3 bells tall. I have a doubt on this question. Find the smallest number. Naren, you have to actually follow the same steps as this one. Okay. Smallest number is given in the question. That is why you find the LCM first and add 5 to the final answer. Whatever LCM you get, you add 5 to that. You will get that is the answer. Clear, Naren? Work, tell me.
Yeah, I did that, sir, but still I got the answer wrong.
What is the answer given?
Something like in 20, sir. I don't know. I didn't see the answer. Matlab, I did it, but still I don't remember.
Then you work it out again and send it to me on WhatsApp. But the procedure is you have to find the LCM and add 5 because your question has 5. Which one divided by 16, 20, 24? You find the LCM and add 5 to that. Okay, that will be the answer. Okay, and with calculator also you can divide and check. Okay, you can using calculator also you can divide and check. It will come. Answer will come. Okay. If you're not getting, let me know on WhatsApp. We'll discuss. Okay. Okay, it's very similar question. Exactly similar numbers alone have changed. Okay. Okay, let's do this question, everyone. 3 bells tall. Tall means ring. Okay. Or maybe I'll write ring itself. Okay. 3 bells ring at intervals of 2, 3, and 5 minutes respectively. So I'm having 3 bells. This is bell number 1. Okay. This is bell number 2. And this is bell number 3. 3 bells ring at an interval of 2, 3, 5 minutes respectively. If they start tolling means ringing together, if they start ringing together, after what time will they next toll together? See, Suppose I have a switch for all of these. I have a switch for all of these. Okay, I have a switch. Okay, I'm having a switch somewhere. Okay, in my house. Okay, I'm having 3 bell. Okay, I'm having a switch. Okay, so all of them I on at the same time. That is what is the meaning of if they start ringing together. All of them, no, all of them I start at the same time. If they start ringing together, okay, all of them you're starting at the same time. See, if you all of them, if you're starting at the same time, this will ring every 2 minutes. Every 2 minutes. So 2, 4. Maybe I'll write here. The first bell will ring to second minute, it will ring. Then see if you start all at the same time. See, suppose you start at 10 o'clock. For example, all the bell, no, you ring the bell at 10 o'clock. For example. So all the bell will ring at 10. This bell number 1 will ring at 10, 10 2, 10 4. Okay. 10 6, 10 8, 10 10, 10 12, 10 14, 10 16, 10 18. Because every 2 minutes it will ring, right? Yes or no, everyone? Yes. 10 20, 10, 22, 24, 26, so on, so on, so on, so on, so on. Second bell is ringing every 3 minutes, right? See, all of them we are starting together. But this bell will ring again at 10 2. And when will this bell ring? 10 3. Because every 3 minutes on it will ring, right? So second bell, 3, 6, 9, 12. Mute yourself, Naren. 15, 18, 21, 24, 27, 30, 33, like that. Okay. Yes or no, everyone? Next, the other bell. Okay, third bell. Okay, third bell. There's a third bell. Maybe I'll write the numbers itself. It will be easy. Otherwise, you'll get confused. So 2, 3, and 5. So 5, 10. Okay, 15, 20, 30, 35, 40, 45, 50, so on, so on, so on. Okay. You have to understand the concept. If you start all the 3 bells at 10 o'clock, this bell will ring 10 2, 10 4, 10 6, 10 8, like that. This bell will ring 10 3, 10 6, 10 9, like that. This bell will ring 10 5, 10 10, 10 15, like that. Okay. Now, you are starting all the 3 bells at the same time. 10 o'clock. After what time will they next all together? Okay. Will the next all together? Okay. See, all the 3 bells you started at 10 o'clock. Okay. So if you see the like numbers here, see, you actually have 12, not 12. Okay, 1 minute. Okay, I have to keep writing multiples basically. Okay, 1 minute. I have to actually write few more multiples. Okay, 26, 28, 30, 32, 34. See, if you look carefully, if you see the multiples of this, you have 30. If you see the multiples of this, you have 30. And if you see the multiples of this, you have 30. See, if you keep writing, you'll get more multiples. But the first common multiple, the least common multiple is this only. The least common multiple is this only. That means all the 3 bells will ring again at 10:30. Yes or no, everyone? If you start at 10 o'clock, again, all the 3 bells will ring at 10:30 only. 10:30 only they will ring together. Okay, 10:30 only they will ring together. Now, we cannot follow this technique to solve questions in the exam. Okay, this technique is very time consuming. I have told this is only for understanding. Okay, so whenever you have a concept of repetition, whenever you have situation of repetition, something is repeating, you have to find LCM. You just keep that in mind. Whenever something is repeating, you have to find LCM. So it is going to repeat, right? You have to find LCM. So see, least common multiple, right? So multiple means you keep multiplying, right? It's whenever there's a case of a repetition, you have to find LCM. So now, how to present this answer? See, if you write like this and all, they will not give any marks. This is only for understanding. I have given this concept, okay? So how will you write? You will say that, you'll actually write one statement. I'll write that for you, okay? Maybe. Shall I erase all this? Actually, not required. Okay. This is only for understanding purpose. I have written all this. This is not required for the exam purpose. But if I just tell you the method to do it, no, without explanation, it will be difficult. You may forget also. But now you'll never forget. Okay. You have understood. So I'll write. See, whatever is given in the question, no, that will write as introduction. Okay. So we'll say the three bells toll together again at LCM of 2, 3, 5. Okay. So 2, you can write just 2 to the power 1. 3, you can write 3 to the power 1. 5, you can write 5 to the power 1. So what is the LCM of 2, 3, 5? 2 to the power 1, 5 to the power 1, 5 to the power 1. 6 was a 30. That means they will start tolling together in 30 minutes. Okay. So if you start at some time, in 30 minutes again, they will start tolling together. Yes or no, everyone? Yes. So you write one conclusion, they will toll together. They will toll together again in 30 minutes. Sometimes they will ask time also. For that, no, they will say that all the three bells were started at 10 o'clock. That means 10:30 they will toll again. Sometimes they'll give time also. So you can understand. See, 30 minutes means what? If it's 10 o'clock, you start, 10:30 will ring again. Yes or no, everyone? Suppose LCM was coming out to be 180. Suppose I'm saying 180. Suppose LCM was coming out to be 180. See, 180 minutes is 3 hours. So 10 o'clock, if you started, 1 o'clock, they will ring again. Yes or no, everyone? Yes or no, everyone? Okay. So now, can you all just quickly try out? I actually have a class for 9th standard right now. Okay, but you can try out this question quickly, and then we can stop. Try out. Quickly, you try out. Do not write steps. Just do it and tell me the answer. Dylan, if you read the question, they have already told that if they first ring at 6 a.m. together, at what time? You can easily tell the time. You have got the answer also. Very good, Arush. Very good, Dylan. That is correct. Very nice. See, I'll not write the steps here. You have to write the steps as I have actually told before. Okay, the answer is we have to find the LCM of this. How to find the LCM of 4, 12, and 20? You have to follow the prime factorization technique. If you take 4, 2 2s are 4, 2 1s are 2. If you take 12, 2 6 are 12, 2 3s are 6, 3 1s are 3. If you take 20, 2 10s are 20, 2 5s are 10, 5 1s are 5. So 2 to the power 2. 12 is 2 to the power 2, 3 to the power 1. Okay? And 20 is 2 to the power 2, 5 to the power 1. How do we find LCM? LCM, don't take anything common. Whatever is there, you put the highest power. Whatever prime factors are there, put the highest power. 2 to the power 2, 3 to the power 1. Okay. 4 to the 12, 12 is 60. 60 minutes is the LCM. Now, if they first ring at 6 a.m., again in 60 minutes they will ring. That means they will ring together again at 7 a.m. Because 6 a.m. they're ringing together. Again in 60 minutes they will ring. 60 minutes means 1 hour. So 7 a.m. again they will ring. Yes or no, everyone? Yes or no, everyone? Please, everyone, my humble request, revise and come. Revise and come. Okay. Next class, we'll discuss few more questions of this type, but revise and come. With this, we stop. If anybody is having a doubt in whatever we have discussed so far, you can wait and ask. If you don't have a doubt, you can leave. Thank you so much, everyone, for joining in. Take care. Bye-bye and have a great evening.
Thank you, sir.
Good evening, sir.
Yeah, tell me.
Happy
Sir,
Teachers Day, sir. Thank you, sir.
This one, 160 pages long notebook is enough, sir.
Yeah, more than enough. Yeah.
Okay, sir.
Yeah.
Thank you, sir.